Encapsulation. Encapsulation is when a class is wrapped up into a black box, when all of its inner workings, including static and non-static fields and some methods, are hidden from other classes. It is said to be encapsulated. Data in the class can then only be accessed by public methods. This can be done by making all instance variables and fields private and then creating public methods to set and get the values for the variables. Encapsulated classes have methods that do nothing but allow other classes to read and write their fields. A method that reads a field is called an accessor, or sometimes a getter, because it gets a value. It always has a return value and usually no parameters. Here is an example. It's good practice to include the word get in the name to remind you and others what it does. This one is getCount, and it returns count. In non-void methods, a return expression compatible with the return type is evaluated, and a copy of that value is returned. This is referred to as return by value. If the return type is an object, only a reference to that object is returned. A method that writes a field is called a mutator, or sometimes a setter, because it sets a value. It always has at least one parameter and usually no return value. So here we have our method setCount. It takes new count in as a parameter, and there's no return value. It has void. It's good practice to include the word set in the name to remind you and others what it does. We will soon see some examples of accessors, getters, and mutators, setters. Here are the advantages of encapsulation. Number 1, data hiding. Users have no idea about the inner implementation of the class or how the class stores values. 2, increased flexibility. You can determine which variables of the class are read-only or write-only depending on the requirement. 3, reusability. Classes can be easily changed and reused because all information is encapsulated in one place. 4, testing code is easy. Your standard classes, such as the string and math classes, are encapsulated. You will never need to see inside them or know how their code is implemented in order to use them. The best way to describe encapsulation is to implement it. Let's write a class that stores employee information. We're going to declare private fields for the employee's name, age, and employee number that will be assigned upon hiring. Create a static field to keep track of the total number of employees. This will be static because you do not want anything outside of the class affecting your employee count. In our earlier restaurant program, we could directly assign the number of tables to the server class or instance of it by using server.numTables equals 5 or katie.numTables equals 3. This time the fields have been declared private, so you cannot access them the same way as before for security. Instead, we create public user-defined methods that can be invoked by outside classes to store and retrieve data from the private fields. First, create a method that when invoked by another class will take data from that class and store it in your private fields for name and age. So here we have two setters. So if another class runs this method, so say they say set name, and then you put a name in here, so Katie, it's going to then set the name in this class equal to Katie. And the same thing for age. Here we're setting the age to whatever we put in these parentheses in another class. Next, create a method that for every employee object created will increase the total employee count and assign each with an employee number. So here we have another setter method. It's going to set the employee number, setNum. This increases the employee count by 1 for every employee hired, and then it assigns the current hire number as their employee number. So note, you could also assign employee numbers to be random using math.random, but what problems might arise if you did that? Because this class is encapsulated, only those with access to it will know how an employee number is calculated. Anyone else would simply invoke the method within their own class when they want a new employee to be assigned a number. We will see how soon, but for now, we still need to create some methods to retrieve the data we stored with our set methods. Use get as part of each of these method names for ease of readability. You will need one for each field you allow other classes to gain access to. These methods are simple as they only need to return the private field. So here we have our getters, getName, getAge, getNum, and each returns what they're holding. So name is a string, so it's going to return string, age is an integer, and the employee number is also an integer. So let's use this class. You are a company looking to keep track of your employees and have access to the employee class with the following information only. Class employee stores and retrieves name, age, and employee number. We can send the parameter name to the setName method. We can send the parameter age to the setAge method. We can get back the employee name from the getName method. We can also get back the employee age from the getAge method, and we can get back the employee number from the getNumber method. Implementation is not shown. Notice that the specifics of how the class was constructed are not previewed to you. Let's create a company class that will have access to the scanner. So we have our import statement, public class company, and our main method. You will need to create a new object and a simple loop to ask for more than one employee's information. So we're going to create a new employee. New hire equals a new instance of the employee class. Car answer equals y, and then here's our loop. So while the answer does not equal n, something's going to happen. Now, the user needs to input the name and age of each employee. So we're going to print out name of new employee. Then the user enters a name, and whatever they enter is going to be right here, and we send that as a parameter to our setName method, and we're going to call it on our new hire variable here. So it's going to set new hire's name to be whatever they input. And then we do the same thing for age. Age of new employee, send whatever they input as the parameter to the setAge method. While there's no input necessary to calculate the employee number, we do need to invoke the method that will retrieve a new number to associate with the employee. Then we can output the employee information with their number. So we have to call this method here. NewHire.setNum, that's going to calculate a new employee number for them. And then we can print it out. So the employee number for NewHire.getName, so this is going to print out their name, comma, their age, comma, is, and then we can get the number instead of set the number. See here we set the number, here we get the number, and it'll print it out. Because the employee class is encapsulated, we cannot directly print the values stored in the variables. We must invoke the classes that will retrieve and return the values stored. That's the reason why methods are public with encapsulation. If you do not wish for an outside class to access a method, you can choose to make it private. Finally, let's finish the while loop. So we're going to ask the user, would you like to enter a new employee, Y or N? Then we're going to ask them to enter the letter, and we're going to save their answer in this variable answer. You have now created and used your first encapsulated class. Compile and run this a few times. Make notes about your observations. Anything you notice in particular? Any pitfalls in the code? While emp count will keep a running tally, The other fields will be overwritten after output due to use of only one object, new hire. An instance for every employee is necessary, and we can't output new hire with all the values stored.